Today, we will be taking a closer look at the winter night sky. This season provides us with incredible views of some of the most iconic constellations in the heavens. They are full of myths and legends that are usually based around Greek mythology. In 1926, the International Astronomical Union decided to standardise the night sky, using Greek heroes and legends to describe the constellations we see from Earth. They defined 88 constellations in total, spanning both northern and southern hemispheres, 46 of which are visible from our perspective in the northern hemisphere. These constellations are not all visible at the same time, but can be seen as the seasons change over the course of the year. Winter constellations highlights include Orion, Taurus, the Bears Ursa Major and Ursa Minor, Gemini the Twins, and Leo the Lion, all the way back to Draco, Cepheus, and Cassiopeia. These names may sound familiar, however, finding these constellations in the night sky is a very different matter. We begin our winter journey through the skies looking north, which includes the famous constellation Ursa Major. This great bear dominates the northern part of the sky and is a very useful constellation for stargazers. The easiest way to identify Ursa Major is to find this pattern or group of other constellations known as an asterism. This particular one happens to be made up only from stars located in the constellation of Ursa Major. And these 7 stars form a very interesting shape. Many of you may know this as the Big Dipper or the Plough, though in South Wales it's called the Saucepan. Around the globe its name differs. For example, in Italy it is known as the Cart. The 7 stars that make up this asterism are very useful when stargazing. The 2 stars at the end of this bowl shape are also called the pointers. As we draw a line between these 2 stars and extend it about 5 times the distance, we end up here. This is one of the most important stars in the night sky, Polaris, the North Star. Polaris's visible position in the sky depends on your location. Its height in the night sky is dependent on your current latitude, so, for most of the southern part of the UK, Polaris sits at around 51.5 degrees above the horizon. If you were to go further north, then it would get closer to the zenith, which is the imaginary point right above your head. Standing at the North Pole, Polaris would appear directly above you, but moving closer to the equator, Polaris drops closer to the horizon until it eventually disappears. The stars of these mythical constellations are joined together in folklore. To the Greeks, Ursa Major was a maiden named Callisto, who had fallen in love with the god Zeus. They eventually had a child called Arcus, which angered Zeus's wife Hera. In her rage, she turned Callisto into a bear, leaving Arcus to be raised by another family. He grew up not knowing the true story of his birth, who became a fine hunter. One day, whilst out hunting, he spotted a great bear. This was Callisto. Upon recognizing her son, she reared up onto her hind legs, arms wide open, ready to greet him. However, to Arcas, a great beast was bearing down on him, and instinctively drew his sword, ready to defend himself. Zeus, who was watching from the heavens, decided to intervene and stop Arcas from slaying his own mother. Descending from the heights of Mount Olympus, Zeus stepped between Callisto and Arcas, explaining everything to him. Arcas was devastated that he had been parted from his mother for so long and put in a position that almost had him kill her. However, Hera's punishment stopped Callisto from becoming human again. So, Zeus transformed Arcas into a bear too. Grabbing them both by their tails, he started to swing them round his head. As he did, their tails grew longer and longer until he couldn't hold on any more, and the bears flew up into the night sky, where we find them today. That is just one of many magical tales set in the northern part of our skies. As we move around towards the east, just below the Great Bear, we reveal more constellations. One of the easiest to spot in this area is Leo. With the characteristic shapes at the front of his head and his tail. Removing the figures from our sky map, these shapes become easier to see. The pattern that makes up Leo's head is known as the sickle, or the backwards question mark. The three stars that make up Leo's tail form a recognisable right-angle triangle. Both features make Leo an easy find in the night sky. Leo is thought to represent the Nemean lion of Greek mythology, but the shape made by all of its stars can also be likened to another legendary lion, the Egyptian Sphinx. Leo, along with the other 11 star signs, are most famous for being signs of the zodiac, given to us by the ancient Babylonians. In front of Leo, we have the constellation Cancer, and moving forward we see Gemini, Taurus, Aries, and Pisces. Over 4,000 years ago, the Babylonian civilization used these 12 constellations as a rudimentary calendar, which allowed them to progress from a society of mostly hunters and gatherers to an agricultural civilization, which was a huge step in humanity's evolution. They were able to use the stars to predict when the weather was going to change, and were able to plant crops and shelter their animals safely in the winter. The Babylonians were one of the first early civilizations to effectively use astronomy, but our next focus predates even them. This is Orion, the Hunter. The stars that make up this constellation also draw a memorable shape in the night skies, the most famous of which are the three bright stars that make up Orion's belt, which are, from left to right, Alnitak, Alnilam, and Mintaka. His shoulders are also very bright, which are the stars, from left to right, Bellatrix and Betelgeuse, and at his feet we see Rigel and Scythe. Hanging from his belt, we can see the stars that make up Orion's sword. As we zoom in towards these 3 points of light, we begin to see a nebula. A nebula is an area of space composed of dust and gases, and although Orion's position in the sky is full of dust and gas, commonly called the Orion molecular cloud, Orion's sword contains the spectacular Orion Nebula. Near to Orion's belt, we can also see the Horsehead Nebula and the Flame Nebula, which have been a popular subject for deep space photography for many years. These well-known nebulae are dwarfed in size by this red bubble of gas. This is known as Barnard's Loop, and the red colour we see is formed from hydrogen gas in space. This molecular hydrogen is releasing energy at a low enough frequency that it glows a beautiful dark red in our night skies. Looking closely at Orion's sword, we can get a better view of the Orion Nebula. The red and the blue colours indicate two different processes occurring within the gas cloud. The red, as we mentioned previously, is the molecular hydrogen cloud where new stars are being formed. The blue colour within the nebula is caused by the gas and dust reflecting the blue light from the larger stars within the Orion Nebula out into space. This scattering effect is similar to what we see in Earth's atmosphere, where the sun's light hits the upper atmosphere and is diffracted. Because of its shorter wavelength, blue light is more easily diffracted by the dust and gas molecules in the upper atmosphere, causing our skies to look blue. Looking at the left side of the nebula, we can see the shape of a running man, with his head, arms and legs extended out as if he's in full stride. Within the darker patches of the nebula, the Hubble Space Telescope has discovered numerous unusual shapes, known as propylids. This is not only where new stars are formed, but also new planets. If we have new planets forming, then there is the possibility of new life. Using a technique known as mass spectrometry, we can break down the chemical components found within the nebula. These chemicals form the building blocks of life, DNA and amino acids. As we move away from the nebula to see the wider winter sky, we see the constellations of Taurus and Gemini, but also a horseshoe shape of stars here, known as Orion, which includes the fairly bright star Capella. To the left of Capella we see the twins Gemini, and to the right we see another famous face, Perseus. Next to him we have Cassiopeia, which is this W in the sky. Cepheus sits in the sky forming this house shape. We can see a roof, the walls and floor here. Below that we have Andromeda and Pegasus, the winged horse of the gods. Next to this we have the sea monster Cetus. All these constellations join as part of a rather large story in the night sky. This story involves Cassiopeia. If you look closely, you can see that Cassiopeia is sitting on a throne. However, you'll notice she's upside down. Sitting in this position because of a punishment involving her daughter Andromeda. Looking carefully, you can see she has chains around her waist and hands. The story really begins with Queen Cassiopeia and her husband Cepheus, who were the rulers of a land called Ethiopia. The queen was beautiful, and so was her daughter, but also incredibly vain. You can see she is holding a mirror in her hand. she would proclaim to anybody listening that she was the most beautiful woman in the entire world. Well, this irritated and upset a group of women called the Nereids, who were the daughters of the sea god Poseidon. To punish Cassiopeia's arrogance and vanity, Poseidon lets loose the sea monster Cetus. You may also recognise it by its more familiar name, the Kraken. If you look closely, it appears to have the head of a dragon on the body of a whale. This monster's goal was to flood the land over which the king and queen reigned, putting the lives of many, many people in danger, and King Cepheus did not want to see his subjects suffer. After consulting with 3 wise witches, they told him the only way to save his lands and people was with the sacrifice of his only daughter Andromeda. So, one evening, he took Andromeda and chained her to a cliff at the shore, and there she awaited the arrival of Cetus, who had come to devour her. Luckily for Andromeda, Perseus was travelling back from defeating the Gorgon, Medusa. Now, when you look at the constellation, you can see the 2 bright stars representing the eyes of the Medusa in the hands of Perseus. He defeated Medusa by chopping off her head, and as he did so, the blood from Medusa's head fell to the ground, giving birth to Pegasus. Looking down, Perseus saw Andromeda chained to the cliffside. Wondering what she was doing, he flew down to investigate. Andromeda, relieved to see a friendly face, explained what was going on. Rushing back to Pegasus, they flew to the top of the cliff where the king and queen were awaiting Cetus's arrival. Perseus, who had shocked them with his appearance, explained that he would save their daughter, lands, and people if he was allowed to marry her. The king agreed without hesitation to Perseus's request. Without a moment to spare, Perseus hurries back to shore, awaits the arrival of Cetus. Ground shaking and waves crashing into the shore rocks, Cetus emerges out of the sea. As its enormous hand extended out to take Andromeda, Perseus pulled the head of Medusa from out of his bag. Cetus's eyes met Medusa's glare. The monster slowly turned to stone. The next waves that came in smashed Cetus into 1,000,000 pieces, saving the lands and people of Ethiopia, but also saving Andromeda. Now, you'd think that would be the end of the story, but on the eve of their wedding, Perseus was informed by the gods that Cassiopeia, who did not like him, had arranged for an army to come in and kill him. For protection, Perseus decided to take the head of Medusa with him in a velvet bag. As the ceremony began, the army burst through the doors. Perseus quickly turned to Andromeda, telling her to cover her eyes, and not to open them until instructed to do so. He plunged his hand inside the velvet bag and pulled out the head of Medusa, turning the whole congregation, the assaulting army, and his future mother and father-in-law to stone. Once the commotion had ceased and all was silent and still, he placed Medusa's head back in the bag and left with Andromeda. It's quite a nice story of the sky. As you can see here, they dominate this part of the sky around Orion. In between these mythological heroes and monsters lies the large constellation of Taurus, the bull. In the Orion Nebula, we saw the first stage of the birth of stars. Here in Taurus, we get to see what follows. This slightly small cluster of stars is called the Pleiades, or the Seven Sisters. Covered by gas, this group of stars appear blue because of how extraordinarily big they are. In the context of astronomy and in the scope of the universe as a whole, blue objects tend to be hot, while red objects appear cold. The blue light, as we've seen with the Orion Nebula, is scattered by dust and gas, and what should be just in front of this new star cluster. But a cloud of dust and gas which scatters the blue light and gives the nebula its wonderful appearance. These stars are still very young in their lifetime, only a few million years old, and in a universal scope, stars can live for hundreds of billions of years, depending on their size. Looking slightly to the left of our moon, we can see a V shape, which represents the face of Taurus. We also have this red star, known as Aldebaran, that represents the bull's eye. It's also known as a red giant star. A red giant is a star that has exhausted all of the hydrogen in its core. The birth of a star is characterized by a process called fusion, where hydrogen atoms start to form bonds with each other, releasing massive amounts of energy through heat and light, with the byproduct being the element helium. Over millions of years, the hydrogen inside the core of the star begins to run out, and helium becomes the primary element. At this stage, the star begins to contract and decrease in size. As the star contracts, the gases in the core are compressed, heating up. A practical experiment you can try yourself to see this effect in action is to pump up a football. As more air is pushed into the ball, the valve will become hotter and hotter. It's at this point where the massive amount of gas inside the core of the stars starts to pull closer together by gravity, becoming extremely hot. The reaction inside the star reaches a point where helium can start to fuse together to form carbon, but because there's so much energy in the core, the temperatures increase enormously, and it causes the star to become much, much bigger, becoming a giant star. As the outer areas of the star are now much further from the core, they cool down and take on a red colour, forming what's known as a red giant. As stars reach the end of their lifetimes, they can die in two different ways. Smaller stars, like our Sun, would end with a planetary nebula. But larger stars die in massive explosions that form supernovae. A supernova is the result of a star up to 10 times bigger than our Sun exploding. The Crab Nebula, also known by the name M1, is an example of this phenomenon. This spectacular feature is the first entry into a catalogue which was put together by a man called Charles Messier. The catalogue contains 110 entries in total, but this is the only supernova remnant within that catalogue. It was probably first recorded by Chinese astronomers and the Native American Anasazi tribe, as the explosion occurred in the year 1054 and would have been bright enough to be seen during daytime. What we see here is shockwaves within gas, because as the star exploded, all its gases are pushed away, and the shockwave from the explosion then travels through them. Using powerful mass spectrometers, we are able to detect many elements from our periodic table, formed from the massive release of energy. However, this was not the true end of this star's life. Hidden deep within this cloud is a mysterious object known as a neutron star. The famous British astronomer Dame Jocelyn Bell Burnell discovered a pulsar within this nebula, which is a quickly repeating radio frequency caused by a rotating neutron star. It was the first one ever recorded. When she spotted it on her radio telescope, she wrote a small note on the tracing which read LGM, which meant Little Green Men. She thought she might have found an artificial signal being sent by an alien civilization. It was only after more research by herself that she discovered many, many more of these pulsars in the sky and understood the process that caused them. The other type of nebulae, the planetary nebulae, was discovered initially by William Herschel. He named them planetary nebulae because to him, the nebulae themselves looked a lot like planets, and in particular the gas giant planets like Jupiter and Saturn. When we look at this one, the Ring Nebula, which is in the constellation of Lyra, these objects have a central star which is the core left behind from a sun-like star. Imagine a huge diamond that was 50,000 degrees Kelvin in temperature. This is a white dwarf. Surrounding it, we have a ring of gases, which is the old shell or atmosphere of the star. Over time, the gases will disperse and disappear, leaving the white dwarf at the centre. Returning to where we began our journey, there are still many wonderful constellations visible in the night sky. The last prominent feature is this arc of stars spread across our night sky. The Milky Way, our galaxy. It contains approximately 300 billion stars. During the winter, the Milky Way looks dim, but during the summer months, it dominates the sky. When we first look at the Milky Way, it appears to be a cloud. And in some respects it is, but not the type of cloud that you think. In fact, this is just a cloud of light, and within it we see these dark patches known as dust lanes. Here is our first example of another galaxy. Very close to the constellation of Andromeda, we can zoom in to the middle of these two stars. Then moving up a little bit further, we will come across the Andromeda Galaxy. The Andromeda Galaxy is our nearest galactic neighbour. At around 2.8 million light-years away from us, which is relatively close in galactic terms. It also gives us a good indication of what our Milky Way looks like. We see the core or central nucleus of the galaxy here, and then surrounding it we have these spiral arms. Our viewpoint of the Milky Way from Earth is slightly different than what we see here. If this was our Milky Way, we would be located around 2/3 of the way out, within one of the spiral arms. If we draw a line through the middle of that galaxy, it would be known as the galactic plane. Our solar system sits slightly above that line in the Milky Way, which gives us a unique viewpoint into space. We can see towards the middle of our galaxy in the summer months, but in our winter months, we're able to look out into deep space, allowing us an excellent view of these other galaxies. The Milky Way is around 130,000 light-years in diameter. Light-years are a measurement of distance, and 1 light-year is the distance light travels through space in 1 year on Earth. So, it would take light 130,000 years to cross our galaxy. When we start to consider the possibilities of other stars like our Sun having planets, looking at a galaxy like this one, there are potentially 80 billion other planets. Out of those 80 billion, we must wonder, how many have life? We hope you've enjoyed the Planetarium show, and we hope to see you in the future at one of our Dark Sky Wales events. Look out for updates on our Facebook page or via our website, or any other social media for new shows that will be appearing soon. In the meantime, take care and clear skies.